Okay, we're here at gotomath.com doing a little calculus here and there. Let's click on concavity. Find the concavity of the graph. Okay. 8-1. Looks like this would be a fun problem. So we got find the concavity of the graph. We got f of x is equal to 0.5 times x squared minus 1 squared minus 1. Now these red dots right here are indicating where the inflection points are located. And so anyway, we'll find the x coordinates of those. But if you want to do some further work, you can kind of find the inflection point also. All right, so let's write that down and move to the board. Okay, and I guess we'll work with blue. So we have f of x is equal to 0.5 x squared minus 1, all right, quantity squared, and minus, I guess minus 1 again. Check that out. Yep, it is. All right, so let's take the derivative. So we take the 2, bring it out front, and a half of 2 is 1, so there you go. All we need to write is x squared minus 1. Subtracting 1 from the exponent, and then take the derivative of the inside, bring it out. 2x and the derivative of a constant is 0. Now the best thing to do here is just multiply this 2x. Distribute that 2x across. We have 2x cubed minus 2x. 2x cubed minus 2x. Okay. And then we'll take the derivative of that. So we have f double prime of x is equal to, so the derivative of 2x cubed is 6x squared minus 2. And then of course we set this equal to 0 and solve for x. So we're going to end up with 2 over x and then the square root plus or minus, it looks like. And of course we can kind of rewrite that. Let's just do that right here. How's that? And switch x around to the left. So that's going to end up being reduced down to 1/3. So we end up with 1 over the square root of 3, which actually can be rewritten as square root of 3 over 3, but we'll just leave it like that. Now let's see here. We're testing for concavity. So we're going to draw a number line, and we're going to put 1 over the square root of 3 here, minus, and then 1 over the square root of 3 here, which is plus. We can definitely use 0 as a test point, and we can use, let's see, that's going to be less than 1, isn't it? So we'll use 1 as a test point, and then negative 1 as another test point. I'm underlining test points here now. Where are we at? Oh, I forgot what the heck we was doing. Okay, so remember, we're only concerned about if it's negative or positive. Okay, that's all we're concerned about. So we take the negative 1, we plug it into the derivative, or the second derivative. All right. So let's do that. So we got negative 1 squared is positive 1. 6 minus 2, so that's a positive number. Right? That's all we care about. Positive number. So that means it's going to be concave up. Right? Concave up. And then we plug from negative infinity to negative 1 over the square root of 3. And then what we're going to do is plug 0 in. So we got h double prime of 0. And all we care is if it's positive or negative. So plug 0 in, you get 0 times 6 is 0. So you get a minus sign. And that means it's concave down. So that's negative, a negative number. And then we plug in a 1 there. plug in a 1 into the second derivative, and we end up with a negative number. Right, so that's a negative number. Like I said, who cares? Don't waste any brain space trying to figure out what these actual numbers are, just their signs. And so that's concave. Whoa. Plug. We should have symmetry here. What's going on? Plug 1 in. Sorry. 6 times 1 is 6, and 6 minus 2 is positive. Well, it's easy to make that a positive. It's like I remember the graph being symmetric. So this should be concave up, right? Not concave down. So we got to watch out for these things. So we're going to end up having an inflection point here because we have a change in concavity. Plus this number is in the domain of f of x. That's important. And then once again, we have a change in concavity here, and this number is in the domain of f of x also. So you have an inflection point here and here, but I think all we wanted was the concavity part. Okay, so concavity, let's see, concave up, we'll say, is the first thing, from negative infinity, and this actually is well, we'll just, did it say to round? I can't remember. What did it, no, it didn't say. So they want the exact value, don't they? So I don't know. We'll just say this right here, but the proper way actually is square root of 3 over 3, right? But we'll leave it like that. So concave up, and then union from 1 over the square root of 3 to infinity, and then concave down is from negative 1 over the square root of 3 to 1 over. Now, like I said, this probably should be written as square root of 3 over 3. Rationalizing the denominator. Let's go over, let's see what, well, as you can see here, so concave up, right, to 1 over the square root of 3, and then concave down, and then concave up. What is the 1 over the square root of 3 anyway? 1 over the square root of 3 is 0.57. So that looks like at about a half right there, 0.5. So this is 0.57 supposedly. Okay. Anyway, let's click that. And let's see, hold our breath here. Right, negative 1, concave up, union 1 over the square root of 3. Yeah. So that's the way I have it written. Anyway, sometimes people don't like radicals written in the denominator. I don't know who got that started, but that's the way it is. Alright, okay, so come on by. You can say hi. Alright, and I'll see you there maybe.